Hi girls, so this is going to be our first lesson in Unit 1, and we are going to be taking a look at real numbers and their graphs today. So what I have for you is something I like to call guided notes that I'll go through with you with a couple of examples and some instances where you can pause the video and try the problems that pretty much look like the examples that we go through together, but feel free to pause and rewind the video as you need to. You can see my picture or my video in the corner of the screen. I think you're going to lose that once I start writing on the screen, just because I have to move my tablet down, but just wanted you to kind of get an idea of what to expect. So we're going to go ahead and get started now. So, oops, no, you don't want to see my face. Okay, so as I mentioned, we're going to be looking at real numbers first. So I have this diagram here that kind of looks like, if you think of gobstopper candy, when you have a piece of candy like that and you keep it in your mouth, you know that the candy shell starts to disintegrate and there seems to be different layers of flavors. And so you think about that, that is kind of like what it means for the subsets of different real numbers. So the big like candy coating is going to be your real numbers. So I'm going to get my pen out here, get my ink tools, and I'm going to write in blue here. So if you could just label in here as real numbers. And then as you get more specific, you're going to move to your rational numbers. So I'm going to write the word rational in this next layer. So rational numbers would be any type of number that you would run across that has either like a terminating decimal, a repeating decimal, or a whole number, positive or negative. And then as we get more specific, we get to integers. So integers would be your numbers, both positive and negative whole numbers, including the number 0. And then if you get more specific to integers, you can talk about something called whole numbers. So that would be your positive numbers that are whole. And then you get as specific as you can to natural numbers. So natural numbers are like the numbers that you learned to count from. So you would start with the number 1, not the number 0. So I'm going to go back in another color and just give you some examples. So let's go actually from the inside out now. So natural numbers would be like your counting numbers, 1, 2, 3, 4, etc. Whole numbers would then include the number 0. So then you have 0, 1, 2, 3, 4, etc. And then integers now include negatives. So let's say we have, let's say -5, and then you could have a +3, and you could have the number 0. So those would be examples of integers. And then your rational numbers include decimals now. So you could have like a -1.3. You could have a -4. You could have 0.2 repeating. So those would be examples of rational numbers. And then you can also include numbers that are irrational when you get into the real number system. So that would be examples of like the square root of 2. If you plug that in your calculator, you'll see that you get a decimal answer, but there's no like pattern to it. Another number that you're probably familiar with is pi. So those would be some examples of what real numbers are: rational, integer, whole, and natural. So you can see that real numbers encompasses all of the number sets that are inside. All right, so now let's take a look at examining these numbers on number lines. So if we take a look at example 1 here, this problem asks us to find the coordinates of the point 2/3 of the way from E to N for the number line shown. So again, we are finding the coordinate points that are 2/3 of the way. So the first thing I'm going to want to do is I'm going to want to locate where E and N are on the number line. So if I look at the letter E, That is right here. So I'm just going to put a dot here, and the letter N. And I'm looking for the coordinate, so basically another letter that is 2/3 of the way from E to N. So you could look at this two different ways. What I like to do first is figure out what is the distance from E to N. So if I count, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 spaces between E to N. So I'm just going to write the number 9 up here. And I go back to my problem. It asks me to find the point that's 2/3 of the way from E. So if I take 9 spaces and I multiply that by 2/3, I can figure out how many spaces I need to move. So if I am multiplying fractions, I can put a 1 underneath of this 9, and I can look at my diagonals. I can cancel or simplify this 3 to be a 1, and this 9 becomes a 3. So then I can just go ahead and multiply horizontally. So I get 6 over 1, which is equal to 6. So it doesn't mean I'm going to find 6 on the number line. What that means is I need to find 6 spaces from E. So if I now go back to E and I count 1, 2, 3, 4, 5, 6, I land on 0, which is letter K. So K is the coordinate for the point that is 2/3 of the way from E to N. The other way you could do that is you could cut your number line from E to N into thirds, because we're looking for 2/3. So since I know there are 9 spaces, I could cut this in thirds. So if I put a line here and then I cut another line here. So now it's broken up into 3 different sections. So this would be 1 section, 2 sections, 3 sections, and I'm looking for 2/3. So this would be 1/3 and then 2/3, and look where I land. I'm at 0 and K, which is the same answer I got. You could do it 2 different ways. All right, so we're gonna, you can go ahead and pause the video to try this example on your own and then hit play and see how you did. So I'm gonna run through this example now. I'm gonna just change it into a different color so I don't get confused with my number line. All right, so use the number line from example 1, and I wanna find the coordinate of the point that is 1/4 of the way from G to S. So I'm gonna go and find G. I'm just gonna put the point down here so I don't mix up what I have above. And then S is here. All right, and again, I'm looking for 1/4 of the way. So I'm going to count and see what my distance is from G to R, or I'm sorry, G to S. Oops, let me erase that. G to S is right here, sorry. Oops. All right, so let's go ahead and count. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 units. And I am finding it 1/4 of the way, so I'm going to multiply by 1/4. So I'm going to put a 1 underneath. I'm going to cross simplify. So I get 3 over 1, which is 3. So I'm going to move my blue dot and count 3 spaces. So that's 1, 2, 3. So I end up right here at J. Right. And again, if I wanted to cut 12 into 4 different, my 12 units into 4 different sections, I would still end up right here. So this would be, if I go 1, 2, 3, and then I'm going to go again, 1, 2, 3. So you can see that if I'm going 1/4, I'd still end up with J. So again, you can use the number line by cutting it into pieces, or you can do the math with the fraction. Okay, let's move on to our next example. Okay, so this one I think seems a little easy, but I just thought I would put this in just to kind of refresh since we're starting the school year, and I know that we got to kind of dust the rust off. So example 2 says to graph the numbers -0.5 and -5 on the number line, and then write an inequality statement comparing them. So my inequality statement I'm going to write that at the end. So first of all, I want to graph the numbers -0.5. So that's going to be about right here. I'm just going to put a dot there. And then -5 on my number line is going to be right there. So now, if I look at a number line, I know that the numbers in red here that are negative, those are smaller. And then my numbers in blue, as you move to the right, they increase. So if I'm going to write an inequality, I'm going to say that -5 is less than -0.5. All right, so go ahead and pause the video and go ahead and try this next example. Okay, so I'm going to switch my color again. So I have used the number line from example 2, and I'm going to graph the numbers 1/2 and -3/2 on the number line, write the inequality statement comparing them. So 1/2 I know is in between 0 and 1, so I'm going to put a green dot right here. And then -3/2, that's going to be on the red side, and that's, if I simplified this, that would be -1 1/2. So that's going to be about right here. So again, if I look at my green dots, obviously the red is going to be smaller, so I can then say -3/2 is less than +1/2. And you probably didn't need to use a number line to do that, but just for our purposes of really making sure we understand it, that's what we're asked to do. Okay, let's move on to our last example for this lesson, which is taking a look at absolute value. So if you recall, absolute value just means the distance of a number to 0 on the number line. So if I think of the number -6, for example, in this example, -6 is 6 units away from 0 on the number line. In fact, if I pull my number line back up here, -6 here, if I counted how many units, that would be 6. So the absolute value of 6 is +6. The other way I like to look at it is anytime you see absolute value, you just take the positive value that's in there. Almost think of it as like a shower stall, and you put a number in and it washes away the negatives. So if I know the absolute value of -6 is +6, and then I'm still going to use that 3 on the outside to multiply. So 3 times 6 gives me an answer of 18. And then for part B, same thing. So I've got the absolute value of -4. I know that's +4. And the absolute value of 6 is +6. Oh, sorry, it is not -4. I'm getting ahead of myself. Let's start that over again. The absolute value of -4 is +4. And the absolute value of 6 is 6. And I'm still going to add these two together, so I get an answer of 10. All right, go ahead and pause the video and you can practice this last 2 problems on your own and then check your answer. All right, so let's go ahead and try to find the value of these expressions. So I've got the absolute value of -9, and then I've got a negative outside. So you have to do the inside of the brackets, absolute value, or parentheses first, according to my order of operations. So this is going to be +9, but then I have this negative on the outside, so that still has to get attached at the end. And then for part B, I'm going to take the absolute value of 4, which is 4, and again the absolute value of -4, which is +4, and I'm going to subtract the 2, so I get an answer of 0. All right, so that does it for this video. We will follow up with a workshop in class and work on some problems. And if you had any questions, just make sure you hold on to them till the next time we meet synchronously. Thanks. Bye.